Hello and welcome to Enhance Smart Skills. If you're a software tester working in telecom, you already know it can feel, well, a little complicated. In this explainer, we're going to pull back the curtain on the network, demystify it, and help you test and talk about it with a whole new level of confidence. So you've been there, right? I mean, we all have. You find a bug, and the feedback you get is, oh, it's a network issue. It feels like this giant, intimidating black box. But you know what? It really doesn't have to be that way. And here's the good news. You absolutely do not need to become a network engineer overnight. You just need a simple, clear way to picture how data actually moves from point A to point B. And that's exactly what we're going to build together right now. Okay, let's get right into it. We're going to break down any telecom network, no matter how complex it seems, into just 3 basic core functions. That's it, just 3. Seriously, everything. From a simple phone call to streaming a 4K movie, it all boils down to these 3 things working together perfectly. So, here they are, our 3 big building blocks. First, you've got access. That's how a device gets onto the network. Then there's transport. That's how the data actually moves around. And finally, switching and routing. That's how the data knows where it's going. Think of them as the front door, the superhighway, and the GPS of the network. All right, now let's put on our tester hats and look at each of these one by one. We'll connect them directly to the kinds of bugs and issues you're probably seeing every single day. First up is access. This is literally the on-ramp, the entry point into the network. When your phone latches onto a cell tower or your laptop connects to a Wi-Fi hotspot, that's the access layer in action. It's always the very first step. So why does this matter to you? Well, a ton of common bugs start right here. Think about it. Call drops, data connection failures, that annoying intermittent connectivity. When a call drops the second you walk into an elevator, or a device just struggles to get a signal, you're almost certainly looking at an access issue. These aren't just vague network problems. They are specific symptoms happening at the access layer. Okay, so once your data gets on the network, it has to go somewhere, right? That's the job of the transport layer. This is the big stuff. The massive, high-speed highway system of fiber optic cables that crisscross the country and even the globe, carrying all that data. Now, problems in the transport layer usually show up as performance issues. You know, if your app suddenly feels sluggish for everyone in a specific city, or you see these weird random spikes in response time, it could just be a traffic jam on that data highway. This is where those dreaded latency problems usually live. And finally, we have switching and routing. I mean, the network has to be smart, right? It needs to know where your data is supposed to end up. This function is basically the network's brain. It's the air traffic control system that's constantly making decisions to guide your data to its final stop. Now, the way networks do this has changed a lot. The old way was called circuit switching. Think of it like booking a private, dedicated road just for your phone call. It was stable, but super inefficient. Today's networks use something called packet switching. Your data, your voice, your video, gets chopped up into tiny little packets that travel independently on shared highways. It is so much more efficient. But here is the crucial takeaway for us as testers. All that amazing efficiency, it comes with a trade-off. Because these packets are all zipping around on shared paths, sometimes they get delayed, they show up out of order, or they just get dropped altogether. And this is where we get those fun terms like jitter and packet loss. It means our testing can't just be about pass/fail anymore. We have to start thinking about the quality of the user's experience. Let's add 2 more really important terms to our toolkit, the control plane and the data plane. The absolute easiest way to think about this is the brain versus the body. The control plane is the brain. It's the smart part that makes all the decisions and sets up the connection. The data plane? That's the body. It does all the heavy lifting, actually carrying your voice, your video, or your internet traffic. So why is this distinction so powerful for us? Well, have you ever seen a call connect just fine, but the audio quality is absolutely terrible? That's a perfect example. It means the control plane, the brain, did its job, but the data plane, the body, is struggling. Just knowing that helps you write incredibly precise and super helpful bug reports. Okay, so we've looked at the individual pieces. Now let's put it all together and see how it builds a complete picture. Because understanding the parts is good, but seeing how they all connect from end to end, that's where you're really going to build confidence. So here's a super simplified flow.
Your phone sends a request, the access network picks it up. The control systems, the control plane, give it the thumbs up. Then your data zips across the transport network, guided by routing until it gets where it's going. And every single one of those steps is a place where things can break and a place where we need to focus our testing.
And this knowledge just completely transforms how you report defects. You can move from just saying, the call failed, to saying something much more powerful, like, the call is failing to connect entirely, which suggests a possible issue in the access layer or with the control plane. Or maybe, the video quality is really choppy, which points to data plane issues like packet loss. You see the difference? That's the difference between a good tester and a great one. By putting all these pieces together, you're not just testing a single feature anymore. You're actually analyzing an entire service flow. You're moving from being confused by the network to feeling really confident about how you test on it. So the next time you find a bug, just pause for a second and ask yourself these questions. Where in that flow could this failure be happening? This simple habit of thinking critically will elevate your analysis and make you so much more valuable to your team.
So let's wrap it up. What are the key things to remember? Every network uses access, transport, and routing to move data. Modern networks, because they use packet switching, have unique quality challenges like jitter and packet loss. The control plane is the brain that sets things up. The data plane is the body that carries the traffic. And knowing all this makes your testing and your bug reports just 10 times better.
Look, this isn't just about learning a few new words. It's about fundamentally understanding the system you're testing on a much deeper level. This knowledge is what separates someone who just executes test cases from someone who is a true expert in quality engineering. If you found this video helpful, please like the video and subscribe to Enhance Smart Skills for more simplified telecom and testing concepts. Thanks so much for watching.